Okay, we're going to go to math.com, click on the algebra. Let's go down to adding and subtracting rational expressions. And we'll have to fill that in. Perform the indicated operations and simplify. So we got 17 over x to the 10th. 17 over x to the 10th plus 3 over x to the 10th power. Alright. Go over here to the whiteboard. So 17 over x to the 10th plus 3 over x to the 10th. So this is just like adding fractions, okay, regular fractions. Like for example, if I had 1/2 plus 2, let's not use 2. Let's use 3, for example. Should have used 17, I guess. In fact, we'll do that. And then 3 over 2. So you see we have a common denominator. So we just add the numerators, right? 17 plus 3 over 2. Okay, gives us 20 over 2, which we could actually reduce that down. Alright. Okay, so same thing's going on here. We got a common denominator, x to the 10th, x to the 10th. So basically all we're going to do here is add the numerators. Okay, so what do we end up with? We end up with 20 over x to the 10th. So there you go. Of course, that's as far as we can reduce that down. Check that out, 20 over x to the 10th. Okay, so over here at go to math.com, doing algebra. Actually, that's the button I meant to click on. Look, there's a dinosaur. Alright, we'll see you later. Bye. Okay, we're going to go to math.com, click on the algebra. Let's go down to adding and subtracting rational expressions. Alright, so this time, as you can see here, we have a different denominator in each one of these fractions. X to the 4th and x to the 11th. So let me write this one down. This is 1.2. So x to the 4th plus 4x to the 11th power. So remember, we always start with easy stuff and then work our way up. Four over x to the 11th. Right. So we need to get a common denominator. And we're going to do that by, if I added x to the, what do we need to do here? 7th. Down here in the bottom, you see x to the 7th times x to the 4th is going to give us x to the 11th, right? But if I do that down here in the denominator, I must do it up here in the numerator also. You see, because x to the 7th over x to the 7th is just 1, right? That's just 1. Alright, so now let's go ahead and rewrite. So we're going to write that coefficient out front here. So we have x, 7 times x to the 7th plus 4. And of course now we have a common denominator. You know what? Let's not skip any steps. It's supposed to be 11 there. Now we have a common denominator, right? We added our exponents, added the powers there, got 11. And so now we have a common denominator. We just go ahead and add the numerators. Plus 4 over x to the 11th. And guess what? We are done. Right? We're done. So we have 7x to the 7th plus 4 over 11. Okay? Alright, so over here, go to math.com. See you next problem. Okay, we're over here, go to math.com, click on the algebra. Let's go down to adding and subtracting, and we're doing 2.1. Get that to come up. Now that's interesting there. So 2.1, we got 2 over x to the 4th plus 2 over x squared. All right. 2 over x to the fourth plus 2 over x squared. Did I say x squared? Well, not a y. Y squared. Oh boy, I wrote x down on my paper. There you go. So we need to get a common denominator. And the way we're going to do this is, if I multiply this side by y squared over y squared, right, and then multiply this side by x squared over x squared, now we have a common denominator. And that's going to be y squared times x to the fourth, or you could say however you want to say that, but I guess that's the way I'll write it out. Okay, well, let's just add the numerators now. So we have 2y squared plus 2 times x squared, and that's all going to be all over y squared times x to the fourth. And if you want, you could actually factor out 2 if you want to do that. Okay, so there you go, and it doesn't matter if you write x to the fourth first and then x squared here, it doesn't matter. All right. So let's see what happens here. 2y squared plus 2x squared. Wait a minute. There we go, making mistakes again. Right, this is x to the fourth. You're probably wondering what's going on here. This should be x to the fourth, x to the fourth. Okay, and actually I wrote x to the fourth down there. Or did I just correct that? I don't know. Anyway. Y squared times x to the fourth. Of course, it doesn't matter which way you write it. 2y squared plus 2x to the fourth power. Alright. Okay, we're over here, go to math.com. See you next problem. Okay, we're over here, go to math.com. Click on the algebra. Let's go down to adding and subtracting. And I believe we're doing 2.2. Alright. So we are writing this down so I can remember it. 17x to the fourth, whoops, y to the fourth, it's not x to the fourth, 6y over x to the fourth plus 17x over y to the fourth power. Got it. We got it. So we have 6y over x to the fourth plus 17x over y to the fourth. All right. Well, as you can see here, I have anything in common here. We got an x to the fourth and y to the fourth. Okay. So we're going to multiply this side by y to the fourth over y to the fourth. And then we're going to multiply this side by x to the fourth over x to the fourth power. And, okay, just making sure. Alright, so now what we got is we got one fraction, y to the fourth, and actually I'm going to switch back over to blue here. Y to the fourth times x to the fourth, and then we just add the numerators. Let's bring this 6 out front. And well, we have a y to the fourth and a y, right? So we can actually join those together and make that, add their exponents. Y to the fifth plus, and then do the same thing here, 17x to the fifth power. All right. That's supposed to be a 17 there. Okay, looks good. 6y to the fifth plus 17x to the fifth. Alright. Six y to the fifth, 17x to the fifth, x to the fourth, y to the fourth. Of course, that order doesn't matter. 6x to the fifth plus 17x to the fifth. Yeah. Alright, looks good. Okay, so we're over here, go to math.com. See you over there, and see you in the next problem. Bye. Okay, we're over here, go to math.com. Click on the algebra. Let's go down to adding and subtracting, and we're doing 3.1. Whoa, we got 3 of them. 3.1. So we have 8 over x plus 2 over x squared plus 3 over x cubed. Alright, got it. 8 over x plus 2 over x squared (3 over x cubed). Okay, so what we're going to need to do here, we've got to get a common denominator, and we're going to multiply this guy by x. Let's look at the highest power here. We've got an x cubed, so we're going to multiply this by x raised to the second power over x to the second power, right? And then this one here, we'll just need to multiply that by x over x, and then we won't need to do anything here. So as you can see here, when we join those together, we end up, now I'm going to reorder this top where we have 8x squared over x cubed plus 2x over x cubed, and then plus 3 over x cubed. So as you can see here, now we have a common denominator, and we just add the numerators. So 8x squared plus 2x plus 3, and it's all over x cubed. It's all over x cubed. Okay. So let's see what we got going on here. 8x squared plus 2x plus 3 over x cubed. Alright, looks good. It all looks good. Alright, so we're over here, go to math.com. See you next problem. Okay, we're over here, go to math.com. Click on the algebra. Let's go down to, what are we doing here? Adding and subtracting something. 3.2, I believe we're looking at. There we go. So we got 10 over x cubed plus 5 over x to the fourth. I guess I need to be writing this down. 0.2. 10 over x cubed plus 5 over x to the fourth plus 10 over x to the fifth. Got it. Okay. So you should be catching on to some of this anyway by now. Just think, you work your way all the way through all these sections, and you should have a pretty good understanding of some algebra that will help you go on to learn trig and definitely calculus. Alright. Be on your way of being a mathematician or an engineer or something. Okay, so what do we need? We got x cubed, x fourth, x fifth. Let's look at the one with the largest exponent. Looks like a 5. So we're going to need to get an x to the fifth over here. So if I multiply this by x squared down in the denominator, but then write x squared up here in the numerator, 2 plus 3 is 5 when we multiply those guys together. And of course this one here is going to be x, just x, over x, right? Because that's to the first power. Alright, and then we'll leave that one alone. So let's go ahead and take that 10 out front there. So we have 10x squared over x to the fifth plus 5x over x to the fifth plus 10 over x to the fifth power. What do we got going on here? Well, we got common denominator, because that's what our goal was, is to get a common denominator. So what do we have? We have 10x squared plus 5x plus 10. There you go. I got that all into one single fraction. 1. 10, 5, 10. Is that what I wrote down? I hope so. I've been known to write crazy stuff down lately. 10x squared plus 5x plus 10 over x to the 5th power. Alright. Looks like that's it. We're over here at gotomath.com. See you in the next video. Hey, we're over here at gotomath.com. Click on the algebra, adding and subtracting, and we're doing 4.1. That's what we are doing. 4.1. So we have 5 over x plus 3 plus 19 over x plus 3. So both these denominators look the same. That's good. That is good. 5 over x plus 3 plus 19 over x plus 3. So since we have common denominator, right, the denominators are the same, then we just add the numerators. So that looks like that's going to be 24 over x plus 3. That's pretty easy, wasn't it? 24 over x plus 3. Seemed pretty easy to me anyway. Okay, so we're over here at gotomath.com. See you in the next video. Okay, we're over at gotomath.com. Click on the algebra. Let's go down to adding and subtracting. We are looking at 4.2. How do you like those apples? Let's see, we got 16 over x plus 5 to the 6th power plus 18 over x plus 15 to the 6th power. Alright. So it looks like these denominators are getting kind of hairy. That's what you want to call it. X plus 15 raised to the 6th power plus 18 over x plus 15 raised to the 6th power. Well, as you can see here, both of the denominators are the same. So what does that mean? That means all we got to do is just add the numerators, right? Add the numerators. And okay. So we got 16 plus 18, and that's that's a miracle, isn't it? There's a miracle going on there. If you can tell me why that's a miracle, send me a message in the comments and tell me why that's a miracle. Alright, good luck with that. Anyway, this is 34 over x plus 15 raised to the 6th power. Got a common denominator. Yeah, that's your homework assignment. Why is that problem, that number on top, a miracle? Alright, there we go. 34 over. You know, since I think about that, I gave that another thought. Anyway, interesting. Alright, so what are we doing here? We're over here at gotomath.com. Checking it out. See you next problem. Bye. Okay, we're at gotomath.com. Click on the algebra. Let's go down to adding and subtracting. What are we doing here? 5. Alright. Let's see. We got 14 over x plus 8 plus 4 over x plus 16. And we're doing 5.1, it looks like. 14 over x plus 8 plus 4 over x plus 16. Got it. We got it. And forgot I actually looked, I thought of something for the first time. I looked it up, and it's close to 34, but It's 33, but never mind. Okay. Which then that's connected to a lot of other stuff. Ooh, it's dangerous when you think too much. 14 over x plus 8. It's like, forget it. Plus 4 over x plus 16. You know you've arrived when you see the world in math expressions and equations. Well, what do we got going on here? We got x plus 8, x plus 16. These are definitely not alike. So we got to get a common denominator here. And we're going to do that. And look at here, I didn't even write enough room. We're going to do x plus 16. Better put 16 there. Over x plus 16. Right? Times 14 over x plus 8. Takes care of that side. Plus, and then we'll write 4 over x plus 16. So guess what I'm going to write over here? That's right, we have an x plus 8, so I'm going to write x plus 8 over x plus 8. So you see x plus 8 over x plus 8 is just 1. Right, and 1 times 4 over x plus 16 is just 4 over x plus 16. It's crazy, isn't it? Okay, well, we got... put this in parentheses here. We now have a common denominator. See that? We have an x plus 16 times x plus 8, x plus 16 times x plus 8. What else do you want? But we got to multiply the numerators. I'm going to take this 14 out front and write x plus 16 plus, and then we got this 4 here. Start a parentheses, x plus 8. Okay? And that's all over a squiggly line. X, I try to make straight lines. It's not exactly easy writing on my bamboo pad here. X plus 16 times x plus 8. Okay, so that's your denominator. Now what we'll probably want to do here is multiply that 14 across, multiply that across, and collect up some like terms, get that in some kind of standard form there. So we end up with 14x plus, and then we got 14 times 16, let's see, that's 140. I'm trying to do that in my head. Plus, let's see, 224. And what do we got? We got 4x plus 32. Okay, so we have 14x plus 4. That's going to make that 18x. Might as well go ahead and simplify that down now. And then we got 224 plus 32 is 256. Right, and then that's all over. And we might want to multiply this stuff out. I can't remember if I do that in the problems or not. We have x times x is x squared, 8x, 16x. 16 plus 8 is 24. Let's see. 24x plus, and then 16 times 8 is this 48 is 128. Alright. Okay, so I'm not sure I go that far. We're going to find out. I think I do. Let's see. We got 18x plus 256. Yeah, I did multiply it out. X squared plus 24x plus 128. Make sure. Yeah, 24x plus 128. Alright. So there you go. And we're over here at GoToMath.com. Alright, see you in the next problem. Hey, we're over at GoToMath.com. Click on the algebra. Did you see there was an alligator down there? That wasn't an alligator, that was T-Rex. I wonder why they have T-Rex on there. I'm disconnected from the internet right now, so that's the reason that's showing up. We got 12 over x plus 5 minus 6 over x plus 16. x plus 16. You're like, when am I ever going to use this? Well, you know, I was doing some art just the other day, drawing a picture, had all kinds of secret messages in it, and it was kind of amazing to me how equations were just popping up everywhere. I would have known. But you got to learn how to read before you can write a paragraph, right? Is that how that works? Right? Before you can write a paragraph? So these are like baby steps to doing something much bigger. We got to learn this stuff. We got 12 over x plus 5, and I wrote 15. Oh my God. I asked for a 13 and they wrote a 31. I think that's how that goes. Minus 6 over x plus 16. Got it. Alright. I think that's a song. I asked for a 13, but they wrote a 31. I think it's a tattoo or something. I don't know. Minus 6 over x plus 16. Okay, so we need to get a common denominator. You should know the drill by now. We have x plus 16. We're going to write an x plus 16 over x plus 16 over here. And then, of course, that's times 12 over x plus 5. Minus, oh, we finally got a minus going on. 6 over x plus 16, and now we're going to multiply this side by, that's right, you guessed it, x plus 5 over x plus 5. What do you know? Let's go ahead and make sure we put some parentheses around this stuff, right, down here in the bottom. But you know what, we'll just do this. We have a common denominator, and that is x plus 16 times x plus 5. And now we tell you what, we're going to do this. We're going to go ahead and bring that 12 out front. X plus 16 minus 6 times x plus 5. Okay. And let's multiply this thing. I think my handwriting's getting worse here. So we have 12x plus, and then we have 12 times 16. Okay, give me a second here. Let me think about that. 12 times 10 is 120. 12 times 6 is 130, 192. Minus, distribute, so 6x and minus 30. Alright. Over. Okay, let's go ahead and multiply this guy out. So we have x times x is x squared. We have x times 5, and then 16x, that's going to be 21x. Yeah, 21x. And then 16 times 5 is, let's see, 30, 80. 16 times 5 is 80, Scribble that down on a piece of paper, make sure. Alright, collect up some like terms. We've got 12x minus 6x. So that looks like that's going to be 6x, and then plus, and of course 192 minus 30 is 162. And that's all over x squared plus 21x plus 80. Man, that was a 4-minute problem, right? Okay. Got that 6x plus 162. Hopefully. 6x plus 162, x squared plus 21x plus 80. I'm like, I gotta scroll up screen real slow, make sure that's it. Okay, so we're over here, go to math.com. See you in the next problem. What was that, 5.2, I think. Okay, we're over here, go to math.com, running from that guy. What in the world is that? We're over here at Algebra. We're doing Algebra. Let's go down to adding and subtracting. That's right, we're learning how to add and subtract. Can you imagine that? And I think we're doing 6.1, I hope. Whoa, what is that? Does anybody know? Alright, we got 2x over x squared plus 7x minus 18 plus 18 over x squared plus 7x minus 18. So as we can see here, both our denominators are the same. And that's good news, right? Alright, so we're going to rewrite all this stuff out just because that's what we do. Minus 18 plus 18 over 8x. Got a disconnect in my brain. Minus 18. Alright, just making sure. So we have a common denominator. So guess what? We just write the denominator since we have a common denominator. And then we just add the numerators. We have 2x plus 18. So what you're going to really see in all these problems, there's going to be more of a plus sign than a minus sign. I don't know, it's just the way it is. But, you know, if you can do plus, then you can also do minus, right? Alright, there we go. Bam. 2x plus 18. Speaking of Bam, he's coming over today. Bam's the, Bam is the grand dog. What's going on here? You know what? Simplify. How many more times am I going to say I think what I did here was we get to this point, everything's good, but we can pull out the 2. We end up with x plus 9. Okay? And then what can happen here is we can factor the denominator. So this will factor to something like this. We got 2 numbers multiplied together gives us negative 19, and when we add them, we get 7. And what in the world could that possibly be? What about a 2 and a 9? If I put a 9 here and a 2 here, that's one of these is going to have to be negative. What about that guy there? And then that's plus, right? Because negative 2 times positive 9 is negative 18. And then when we add them, we get a positive 7. So down here in the denominator, we've got x minus 2 times x plus 9. Well, we can cancel that out and cancel that out. And we end up with 2 over x minus 2. Okay? Something has to be stated here about the domain. However, we're not talking about that. But later on in the story we will. So we're just leaving it like this. But I must say that we must talk about if these two are going to be equal, then we can't use negative 9. But like I said, don't worry about that. We'll get to that later, okay? There you go, 2 over x minus 2. So I clicked on the answer. I saw that. I'm like, oh, I forgot to factor. Okay, so there you go. We're over here at GoToMath.com, getting it figured out. And I'll see you in the next problem. Okay, we're here at GoToMath.com. Click on the algebra. Let's go down to adding and subtracting because we're learning how to add and subtract. Well, we're a little late on that, aren't we? Just kidding. Rational expressions. We have 8x over x squared plus 7x. Did we just do this problem? Because it sure seems like we just did this problem. Oh, it's a minus sign. Okay. But, you know, what's the probability of these same numbers coming up practically? Probability's pretty slim, let me tell you. Ooh, I see something else that's fishy. 72 over, yeah, pretty slim stuff. Okay, so this one here's kind of tricky, and tricks are for kids, right? Tricks are for rabbits, and the rabbit is about to come out and hide the egg. Alright, so we have 8x over x squared, 7x minus 18. I think everybody kind of gets excited when springtime arrives. At least I do. 17 over 18 minus 7x, because I don't care about cold weather. You can have all you want. You can have it. Alright, let's look at this here. We got, ooh, what? What in the heck? 6? Where did that come from? I'm in a 2 and I wrote a 6. Go figure. X squared plus 7x minus 18. In fact, I need to go back and look at that. Wow, okay. Now to get these to be equal to each other, what we could do here is factor out a negative out of this guy right here. So if we pull the negative out, let's do that. Right? That's going to make that negative, that positive, and that positive, and then close parentheses. See that? Now that's a trick. So we have a negative 18, positive 7x, and positive x squared. But I have a negative here, and we have a minus here. So believe it or not, a minus times a negative is positive. Yeah, positive. And then we have a common denominator. Okay, so we're going to skip a step or two here, because you're all grown up now and we can do that. Right, and then since we have common denominator, we'll write that out. Minus 18. Okay, so you with me so far, hopefully? Now I got a feeling here that, of course, for this to be equal to this, we have to state something about the domain, and I have to say that every time. But we're not talking about that yet. That's later on in the story. Okay, but technically these are not equal when we're doing some canceling here. But all right, so keep that in mind. But anyway, in fact, I'll erase that. I'm going to factor out an 8, and that means we're going to pull that out. X plus 9 over. Okay, and let's go ahead and factor the denominator. I think we did this in the last problem, didn't we? Same numbers, kinda? Was it? Yeah. Holy smokeronies. Okay, so what do we have? We had minus 2 and positive 9, right? Negative 2 times 9 is negative 18. Negative 2 plus 9 is 7. And as you can see here, we can cancel these two guys out, and we will be left with 8 over x minus 2. 8 over x minus 2. Did we get that? 8 over x minus 2, yeah. So like I said, we have to state something that we're not stating here, and that is that x cannot be equal to negative 9. We're leaving that part off, okay? We're just kind of focusing on, let's get this, add these together, and let's cancel out some terms, all right? And we'll talk about that other stuff later, okay? But I got to keep mentioning it because I'm going to get some slack on that from somebody. All right, so we're over here at GoToMath.com, just trying to cover the bases. All right, see you in the next Problemo. What time is it anyway? Ooh, we got 23 minutes left of battery life. Whew. All right, see you later. Okay, so we're doing algebra, rational expressions, adding and subtracting, and this happens to be the problem we're on right here. All right. My computer shut down or something, did something funky a minute ago, and so this is not my normal introduction. I've just already have written this problem down, and I don't want to have to start over. So there you go. Okay. I guess we'll have to write it down. Do the first things. We have x squared minus 11x over x squared plus 9x minus 52 plus 13x minus 143 over x squared plus 9x minus 52. So as we can see here, we've got a common denominator, right? Both denominators are the same. So what we'll do then is we'll just add the numerators. So that'll make that an x squared minus 11x plus 13x minus 143, and then that'll be all over x squared plus 9x minus 52. So let's go ahead and collect up the like terms up here. So we end up with x squared, what is that, 2x? And then minus 143 over x squared plus 9x minus 52. Now I have a suspicion feeling that we might want to factor this up here and factor this and see if there's any terms that might cancel out. 143. What do we got on that? I think it might be easier to do 52 maybe, and we'll just write it right over here. We can say equal at this point. Okay, so two numbers multiplied together gives us 52, and then we get 9. The heck could those be? Let's see. Do a little side work down here. 52. So we got a 1 and, well, we got 1 and 52, but I can see that that's not going to work. We got 2 and 26. And that's not going to get us a 9. Now we got a minus sign and a plus sign right here, so one of these is going to have to be a negative, obviously. And probably the smallest number will be negative, right? And what we've been doing in the past is we'd say, okay, two numbers multiplied together, that gives us negative 52, and then when we add them, we get a positive 9, right? So let's take a look at this. We got 2 and 26. 2 and 26. Now, 2 and 26 here, there's no way we can get a 9 here, okay? So let's go ahead and break this down some more. And we know that 26 can be broken down to 2 and 13. So we got another 2 here. And so that could actually be 4 and 13, couldn't it? Now, if we did 4 and 13, we could get 9, right? That's if, let's see, 4 were negative and 13 is positive. We'd be able to get 9, right, if 4 was negative. So go ahead and do that. 4 and 13. 4 is negative, 13 is positive. The reason I started with that is because now we can figure out that if this thing factors up here and we got terms that cancel out, well, it's either going to be a 13 or a 4 that's going to make up this 143, you see. Okay, and I was going to do something, I forgot what it was now. 52. Okay, I was just checking some work there. Let's, normally I don't like to erase my work, but we're going to erase that. And I guess we're going to erase this over here too. Erase that. So we're focusing now on 143. And I'm going to look at 13 here. 13, let's see if 13 goes into 143. And it does 11 times. There you go. Okay. So let's see, 11 and 13. Will that get us a 2? It sure does. Look at that. Because 11 minus 13 is negative 2. But we need a positive 2. So it's going to be a negative 11 then, isn't it? X minus 11 and X plus 13. What do you know? Alright. Yeah, 13 times 11 is 143. So we need a negative 11, right, to get that. And then negative 11 plus 13 is positive 2. Okay. So as you can see here, these cancel out. Okay. Now, I've mentioned this before and I'll mention it again. These are not technically equal when we cancel these terms out. Okay, we would have to state that x cannot be equal to negative 13 here. Alright, for this right here, if we stated x minus 11 over x minus 4, then we would have to state that x cannot be equal to negative 13. And I don't think you can see that, can you? There you go. X cannot be equal to negative 13. Okay. Let's clear out some stuff here. But we'll talk about this later on when we start talking about functions and domain, things of that nature. But in this particular case, we're just talking about the mechanics of simplifying things down. Right, so this would go with this over here. X cannot be equal to negative 13 if both of these are to be equal. All right. Okay, x minus 11 over, looks like x minus 4. I think we spent enough time on that. X minus 11 over x minus 4. And of course, I don't state that right here, but okay. But you need to know. Okay, so we're over here, go to math.com, getting it worked out. See you in the next problem. Okay, we're over here, go to math.com. Click on the adding and subtracting. We are doing 8.1. So we have 15 over x minus 9 minus 16 minus x over x minus 9. That doesn't look too bad. Looks a whole lot easier than what we did earlier. Huh. I don't know. Odd. Very strange. 15 over x minus 9. Normally problems get more difficult as we go along. And then 16 minus x over x minus 9. So as you can see here, we have a common denominator, and I don't know, it's crazy. Alright, well, we have a common denominator, so we just write x minus 9 here, and then go across the top, 15 minus 16. Oh, now let me tell you something. Because there's a minus sign right here, we have to put this in parentheses. See, like that right there? Okay, it has to be put in parentheses. What you could do now is go ahead and distribute that negative across. So we have 15 minus 16 plus x. And then that's all over x minus 9. And of course 15 minus 16 is actually negative 1, isn't it? So we could say x minus 1 over x minus 9. So that's kind of tricky, right? That's tricky right there. So you got to watch out for that. And I guess that's the reason why I put that in there. All right, x minus 1, x minus 9, yeah. Okay, so we're over here at GoToMath.com getting it worked out. See you in the next problem. Okay, so we're over here doing some algebra. GoToMath.com, looking at rational expressions and working on adding and subtracting. And we're looking at 8.2 here. Let's see, form indicated, simplify. Yeah. See, what happened was, the reason we're not doing the normal introduction here is I had already written all this stuff down, and something happened to the microphone. Not exactly right when I was about to end the problem, or close to the end. So I'm just having to redo it now. Okay, where are we at? So I'm trying to save a little bit of time. My battery doesn't last long on my laptop here making these videos. I can't have it plugged in because it makes a terrible humming noise in the background. And I found the best solution for that is just to unplug it while I'm doing the recordings. Okay, so we have negative 12 over x minus 16 minus 5 minus x over x minus 16. So as you can see here, we have a common denominator. Now what I'm going to do here is I'm going to go ahead and take this negative out front, just bring it into the top. So this becomes negative 12 over x minus 16. And then we're going to have, you know what, I guess I won't skip any steps. Just rewrite the problem. We have common denominators, so we can go through and just combine the tops now. Now remember, you want to put a parentheses. Because there's a minus sign out here, you want to start this with a parentheses, okay? So you want to encase this always with a parentheses. And that is an easy mistake to make, let me tell you. So we don't care if it's addition, but minus we do. You'll want to distribute now this negative across. Okay, and so now we end up with, that bar is a nuisance. I've got to just write it over here. So we end up with negative 12 minus 5 and then plus x over x minus 16. And now we can combine that. And I'm just going to reorder that. That's x minus 17 over x minus 16. How do you like that? Okay, pretty easy enough. Yeah, you got to really remember to start those parentheses there. So we got x minus 17 over x minus 16. And if you happen to get both these numbers are the same, which they shouldn't be, right, this would just cancel out to be 1. All right. So we're over here at GoToMath.com getting it worked out. See you in the next problem. Okay, we're over here at GoToMath.com. Click on the algebra. Let's go down to adding and subtracting. And I believe we're looking at 9.1. 9.1. So it looks like we have a little combination of some multiplication in this problem. Adding and subtracting. So we have 9 over x times 4 over x plus 9 over x. That's something a little different. Four over x plus 9 over x. We'll want to, okay, so we could do this a couple different ways. We could go ahead and add these two fractions together and then multiply that result by 9 over x, or we could distribute the 9 over x across inside. And I think what we'll do is we'll do what's in parentheses first. Alright, so we have a common denominator, so we just add the numerators, and 4 plus 9 is 13 over x times 9 over x. And then multiplication, we just multiply the numerators, and so that's going to be 90, 107, 117, yeah, and then x squared, and we're done. Hey, that was pretty easy. wasn't it? Right, 117 over x squared. Okay. So we're over here at GoToMath.com. See you in the next problem. Okay, we're over here at GoToMath.com. Click on the algebra. It's going down to adding and subtracting. We're looking at 9.2. So this looks similar to the last problem. 11 over x to the 11th times 2 over x minus 9 over x. Now I said there's two different ways of doing this problem. And we're going to work what's in parentheses first. And then multiply that result by the 11 over x to the 11th. Yeah. Well, good news is we have a common denominator. So we just add the numerators. Right, and then multiply that result by 11 over x. 11 over x to the 11th, let's say. So this becomes 11 over x to the 11th times, and what do we got? We got 2 minus 9 is 7, negative. It's a negative 7. I'm going to put that in parentheses. I'm putting that in parentheses because if you don't put this in parentheses, it's going to look like 11 minus 7. Okay, so then what we'll do is just go ahead and take that negative out front. And then what do we have? We have 77 over, remember this is a 1 here, so we add the exponents, x to the 12th power. Okay, pretty easy, I guess. What did I say that was? Negative 77 over x to the 12th, yeah. Making sure before we actually see what the answer shows here. Alright, so we're over here at GoToMath.com. See you in the next problem. Okay, we're over here at GoToMath.com. Click on the algebra. Let's go down to adding and subtracting. We're looking at 10 point. What is all that stuff? Are you kidding me? What is this, a test? Wow. Okay. Well, you should have known the last couple problems are always hell. So we have x plus 12 over x plus 17 divided by something that's in parentheses, x over x plus 17 plus 12 over x plus 17, and that's all minus 9 over x plus 14. Alright, amazing. That is amazing. Take me 10 minutes to write all that out. So we have x plus 12 over x plus 17. But it's important that all this does get written out. I've found over time that there needs to be a smooth transition when explaining a problem. You can't really skip steps for the most part. Minus 9 over x plus 14. What we're going to do here is we're going to do what's in parentheses first, and then we're going to take that, do the x plus 12 over x plus 17 and divide it by whatever we get here. Well, good news is they were nice to us. We have a common denominator, so all we need to do is add the numerators. And I am going to skip a little bit of a step here, and that is we're going to go from division to multiplication. Okay, so hang in there. Alright, so if I were to go ahead and join these two together, since we have a common denominator, this just becomes x plus 12 over x plus 17, but then let's flip that, okay? X plus 17 over x plus 12. So hopefully that was a smooth enough transition. Okay, hopefully. Alright. And then we have minus 9 over x plus 14. Okay. But we're going to do multiplication first. Okay. And, well, you know what? I see something going on here. We have an x plus 12 and an x plus 12 here. And are you kidding me? How did that even happen? Those all canceled out. You probably saw that before I did. So now we're left with 1 minus 9 over x plus 14. Alright. We're going to need to get a common denominator. Obviously there's just a 1 down here. And we need an x plus 14 down there. That's what we need. You know what? Let's just write one. We can write an x plus 14. But if we do one down in the denominator, we must do one up here too. Okay, let's put parentheses around that. Fractions are actually pretty easy. People make a big deal out of it. Now that we have a common denominator, we have x plus 14 times 1, which is just x plus 14. Then minus 9. And that's all over x plus 14. Okay, so we'll go ahead and simplify the numerator. And that's going to be 5. Is that right? X plus 5 over x plus 14. Bam. What do you know? So all of that mess reduced down to that. Alright. X plus 5 over, yep, that's it, x plus 14. That was 10.1. God knows what 10.2 looks like. I don't know. We'll find out here in just a minute. So we're over here, GoToMath.com. See you next problem. Okay, we're over here, GoToMath.com. Click on the algebra. Let's go down to adding and subtracting, and we got one more problem left in this section. Wouldn't you know it? It is a mess. Oh my gosh. The last one looked like a mess, but it wasn't too bad. But this one, I'm not so sure about all that. So we're writing this down right now. And I can see we don't have a common denominator. And that stuff in parentheses. Ugh. Cx plus 19. And that's going to be making this problem terrible. 2x plus 29. It's a weird number. It's a number I don't see come up very often, 29. Alright, let me just check, make sure. I got x plus 17 over x plus 10, x plus 17, x plus 17, x plus 10, x plus 19, 12, 2x. Alright, just making sure I got everything going on there. At this point in the game, you should be able to work this problem out if you've been working all the previous problems. And the last section and this section here, I'm thinking you shouldn't have any problems here. Plus 17 over x plus 19 minus 12 over 2x plus 29. I'll make sure there's something here real quick. Yep, minus. Okay, so we'll want to do what's in parentheses first, and you notice that we don't have a common denominator, and that's terrible. We're going to call this some side work here. This is the side work section. Okay. So quickly here, we're going to do what's called, we're going to cross multiply. I'm going to multiply, instead of going through that whole thing, like I said, you should know what we're doing at this point. And then we have plus x plus 17 times x plus 10. Okay. And then that's all over. And you know something? I see something here real quick. And then we multiply these two together. X plus 10 times x plus 19. And I do see something. I hate to have to get on a sidetrack on this, but you notice we have an x plus 17 here and one here. And that means that we can factor out this x plus 17, and this will actually help us than having to multiply all this stuff together. And I'll show you that here in just a second. So we're going to be left with x plus 19 plus, and we pulled that out, so we're going to be left with x plus 10. See that? So you should know how to factor. I think we covered that already. Because there's an x plus 17 and an x plus 17, we just pulled it completely out. And this is what we're left with. And 19 plus 10 is 29, right? It's 29. So we end up with 2x plus 29. That's strange. Okay, and then we have x plus 17, right? And x plus 10, x plus, well, let's see, this 2 doesn't, let's see, 29, no, 2 doesn't go into 29, crud. That's all over x plus 10 times x plus 19. Oh, and you know something? Okay, so we've got a division here. Yeah, I would have been made a big mistake if I'd have multiplied this stuff out. So we've got a division. So with this part right here, we've already worked out. So we're going to go ahead and flip it, and then, yeah, let's see what's going on. Okay, so we're going to go ahead and write x plus 17 here over x plus 10 times, and this part right here, right, this is all the stuff that's in parentheses. We're going to go ahead and flip this, and so we're going to end up with x plus 10, x plus 19, that's all over x plus 17 times 2x plus 29. Okay, and then remember we've got still out here minus 12 over 2x plus 29. Okay, we can cancel some stuff out here. We got an x plus 17, x plus 17, x plus 10, x plus 10, and as you can see here, now look at here, we got a common denominator, right? And okay, well this thing's working out finally. So I'm going to go ahead and rewrite all this. We have x plus 19 over 2x plus 29 minus 12 over 2x plus 29. Well, we have a common denominator. We can add the numerators. Minus 12 over 2x plus 29. And what do we got? We got 19. We got 19 minus 12. And that gives us a 7. So we got x plus 7 over 2x plus 29. What do you know? 7 minutes. Took us 7 minutes to do that problem. And let's see, x plus 7 over 2x plus 29. Well, there it is. Isn't that amazing? Okay, so we are finally done with this section for a while anyway. We're over here, go to math.com, and I'll see you in the next section, which is actually, what is the next section? Complex fractions. Let's click on it, see what it is. Oh, okay, looks pretty easy, I guess. Alright, see you in the next section. Bye. Hey, we're here, go to math.com, click on Algebra. Let's go down to adding and subtracting, and I believe we're doing 7.1. It looks to me like, whoa, what is that? 7.1. See, we got x plus 16 over x plus 17 plus x plus 18 over x plus 4. I've got to write that down. Okay. X plus 16. So it gives you plenty of chances to write this stuff down and actually work it out before I do. That's what you should really be doing. And then x plus 4. All right, so the idea here is we want to get a common denominator, And of course, I should have wrote enough room here. I think I could squeeze this in. So we're going to put x plus 4 over here on this side over x plus 4. And then, of course, over here, because we have an x plus 17, we're going to write x plus 17 over x plus 17. Right. Pretty easy. Now that we have a common denominator, of course, we'd want to put parentheses around the bottoms here, stating that this is x plus 4 times x plus 17. And of course the same goes with the top, but we're going to just go ahead and rewrite that. Alright, so let's just go ahead and combine this into one single fraction. So we have x plus 4 times x plus 17. And then what we've got going on up here at the top is we'll have x plus 4 times x plus 16, and then plus, continue that out, and then we'll have x plus 18 times x plus 17. Boy, that's a mess. Alright, so what we'll want to do now is go ahead and multiply this stuff together and collect up some like terms and so forth. So we have x times x is x squared, and then x times 16, and then 4 times x, add those together, and what do we get? We get 20x, I do believe. And then we have excuse me, 4 times 16, which is 64, 74. 4 times 16, 40, 64, yeah. Okay. Plus, and then we'll go ahead and multiply this stuff together. So we have x squared plus 17x and then 18x, so that's going to be 35x. Make a few adjustments here. Okay. So we'll have 35x, and then we've got 18 times 17, which is 306. 06. And I think what I'm going to do here is, I think I'm going to leave those guys alone for right now. So I'm not exactly sure if this thing's going to factor. I don't think it'll factor. Cancel out terms. I guess we could go ahead and multiply this out, but let's I don't know, x squared plus what do we got, 21x, and then plus 40, 50, 64, 28, 68. Trying to do this stuff in my head. 68, yeah. Okay. Alright, well let's do something with this top up here. So we have an x squared and an x squared, and that's going to give us 2x squared. Then we have a 20x and a 35x, that's going to give us 55x. And we got a 64 and a 306. Or, I should say 306. Plus 370. And that's all over x squared plus 21x plus 68. Okay. So I don't know if this thing factors up here and you can cancel out like terms, you know, who knows. I don't know, let's see what happens here. Remember what we had. 22x squared, 55x, 370. 22x squared, 55x, 370, x squared plus 21x plus 68. Yep. Okay. Alright, well, that looks like that's it. See you in the next problem.